Okay, so we're continuing where we left off on that video, and I apologize for the long video, but just bear with me. We only have a couple more minutes left. So we had our two equations of the car and the truck colliding. So we had the x equation here, which was the negative mass of the truck times the velocity of the truck, equals the after momentum, which would be the mass of the car plus the mass of the truck times the x component of the velocity final. And then the initial in the y is the mass of the car times the velocity of the car equals the total mass, which is the car plus the truck, times the y component of the velocity. So now let's plug in numbers that we know. We're going to take the x equation here, and we're going to say that the mass of the truck, which is 2565 kilograms, and we're going to times it by our velocity, and the velocity is the 17.5, and this is what gives us the negative. And that's going to equal the mass of the two combined. So it's the 2165, which is the mass of the truck, plus the mass of the car, which is 975 kilograms, and it's times velocity final cosine theta. And we do not know what theta is, and we do not know what final velocity is. Okay, so if we clean this up a little bit and plug it into our calculator, we end up with 37,887.5 kilogram meters per second, and this is going to equal a negative 3140 kilograms velocity final cosine theta. If we divide both sides by 3140 kilograms negative, the negatives cancel out, the kilograms cancel out, we end up with meters per second, which is the correct SI units for velocity. We end up with 12.07 meters per second equals V final cosine theta. Okay, so this is going to be one of our equations. We have two unknowns, the final velocity and theta, and we have one equation, so we need another equation. We're going to take this one over here. And I'm going to go up here. So the mass of the car, 975 kilograms, times the velocity of the car, which ends up being 22.5. And this is what gives us the negative because it's going south. And that's going to equal this 2165 plus 975, which is the 3140 kilograms, and V final sine theta. Okay, our two unknowns, theta and V final. If we clean this whole thing up and divide by 3140, we end up with 6.97 meters per second is going to equal V final sine theta. Here is our second equation. So now we have our two equations and our two unknowns. Now for us to solve these, what we're going to do, and I'm going to stick with these two equations. We have two equations and two unknowns. The way that we solve that is we take our first equation and we solve it for one of the unknowns, and then we plug it into the other one. So I'm just going to rewrite the two equations again. We have 6.97 equals V final sine theta. We also have 12.07 equals V final cosine theta. So what I'm going to do is I'm going to take this equation and solve for V final. So I'm going to say 12.07 divided by cosine theta equals V final. All I did was divide both sides by cosine theta. Now what I'm going to do is this, if this equals V final and this equals V final, I can plug this in right there. So I have 6.97 equals 12.07 over cosine theta times sine theta. Now mathematically, all I'm going to do is switch the places here. 6.97 equals 12.07 times sine theta over cosine theta. Okay, those of you that are taking pre-calc and trigonometry, this is one of our trig identities. Those that you don't, we have talked about it before, but just to remember that sine over cosine equals tangent. So we can replace that, 12.07 tan theta. So now we only have one unknown. We were able to get rid of our second unknown, and now we'll divide both sides by 12.07. And so we end up with tan theta equals, let's see, 0.58. Okay, so theta equals the inverse tan of 0.58. If you plug that right into your calculator, you end up with theta equals 30.06 degrees. Okay, so that's our answer for the theta. That gives us the direction. Now we need to go and figure out what our V final is. We can plug it into any of these equations. I'll stick right here, 6.97 equals V final sine of 30.06. Okay, and if I do a little bit of calculations on here, my V final is 13.95 meters per second. So that has given us our final velocity of the collision of the car and the truck, and it's going at 30.06. So if we draw our picture here, the whole mess over here, the truck and the car, are going this way at 13.95 meters per second. And this angle right here is about 30.06 degrees. And that tells us some information. Okay, so that's enough for today. Don't forget to complete the Edline assignment. And then at the end, tomorrow during class, we're going to be doing a whole bunch of these. So hopefully you'll get a hang of it by the end of tomorrow's class. Goodbye, and we'll see you tomorrow in school.